You mother... Hey everybody, how's it going? Today we're gonna be killing the coronavirus on this MacBook. Die, Corona. Die. Yes. Die. And then we're gonna fix it. Die, Corona. Die. Beer virus. The goggles are... It filters out blue light. I kind of like it like that. How can I help you?
Did you...
For those wondering why do I wear a mask in my own office, it's because people who are my staff will walk in every now and then and ask questions in close proximity. And having to put the shit on and off and on and off and on and off is a pain in the ass. If the day is over and I'm the only person here and I'm working on my bicycle, no mask. If I'm standing around 14 employees, mask. 14. Jesus Christ. I can't believe what a bloated company this has become. So many people. Do you miss Paul sitting right behind you? Sometimes yes, sometimes no. When I really need to get work done and be alone, I like to have the lack of distraction because I'm very easily distracted. Yeah, I'm a very easily distracted person. So it helps for me to block. So what I do to get around it is I like to block out the distractions entirely. So I'll ignore everybody. Even if they have a legit question, I will have my headphones on. And I'll do what I need to be doing. So the first thing that I do here, as with every MacBook, is I unplug the battery. Because I want to see how much power the board is taking, not what the battery is taking. Yeah. I'm going to plug in a USB-C charger and a USB-C amp meter. I actually like these UV goggles. What I like... Okay, so one port doesn't do anything. And the other port... I miss throwing junk at the wall at the old store. You didn't work at the old store. Yeah, interesting. One port boot loops. The other port just does nothing. And something tells me that we have a wee bit of liquid damage. That looks like a droplet. Hopefully it's not a corona droplet. Please don't be a corona droplet. Okay, so we're going to take the board out of the machine and kill all of its corona droplets. I'll be glad when you can get your original gloves after beer virus is over. I feel like I'm watching a very kinky porn. Yeah, beer virus I hope really does end at some point. So, the USB-C port itself has seen better days. For certain, this USB-C port has seen happier days. Yeah, this is a sad little USB-C port. This is a CD3215 chip over here. This is a USB-C port controller. So the first thing that I would do is reflow these two chips, because I don't see massive corrosion. I don't see anything indicative of this mass damage. And also, let's just check out what's going on with the probe points over here. Now that red stuff you see is the board bleeding. The board appears to be bleeding. Those probe points actually look really bad. That's not just normal corrosion. That's stuck on there. I can't even scratch that out. I mean, look at this. Like, what is this even? The board. Who hurt this board? Its owner. That's who hurt this board. No, but seriously, like, what is this stuff? There is disgusting shit all over here, and it won't come off. It won't scrape off. Okay, it'll burn off, so I can burn it off. I want to at least get an idea of what probe points are missing and what they're for. Alright, so what is this? Well, that's a good question. We can open up a schematic for this board and see what that stuff is for. So that goes to the CD3215. That's 20 volts. But that's not really... This is not something that matters. So this is something that goes from the CD3215. It goes to this diode, but this doesn't actually have a path anywhere else. Like, it's going to the component. This is just for me to measure, so I don't need it. We have this, the gate of a transistor. Now, if there was a blob of water over here, it makes sense that this is what's going to get the most hit, because you have 20 volts right here. 20 volts is direct charger voltage. That's what's going to corrode the fastest. But it doesn't look like any of the damage over here is anything that matters. It looks like it's just cosmetic. This cap, I'm going to take a look and see if this belongs on the board. That's no stuff. Okay, so what I need to do here is focus on the CD3215, and also on not allowing the 20 volts from this point to get to the actual data lines of the CD3215s. Most likely we're going to need to replace the CD3215s. I don't think that a reflow is going to be good enough here. I don't think that that's gonna get us where we need to be. So I just put some flux there. I forgot to zoom out, so you didn't see that. My bad. We're going to give them a little bit of a reflow with our quick 861DW. I still use the quick over here just because I've been too lazy to take it off my desk and get everything set up at that Atten station. You can see a lot of red stuff coming out from underneath the chip. What that tells me is that there was a lot of dirt under here. A lot of junk. So I want to push down and a little bit, not a lot, because if I push down all the way, all the balls pop out. I just want to make sure those balls are reconstituted as balls. Yeah, that port over here looks really screwed up. This may need an entire replacement port. However, these ports are soldered onto the board and they are not soldered on in an easy manner. This is not like just replacing a DC jack on a PC at all. So first things first, let's see if I have the capability to get 20 volts on the working port. So 5 volts, 900 milliamps. That is not good. That is not good at all. We're not supposed to be taking 900 milliamps. That's insane. And I kind of wonder if that's a result of this actual port being shorted here, because the pins are touching. That could be a part of what's going on here. 800 milliamps. That's crazy. Alright, so let's see if we can measure where our short circuit actually lies here. I'm going to turn on Mr. Paul Daniels' software, which helps us to show you on the screen what it is that I'm looking at. Let's get that started. So I'm going to take a wild guess that the short circuit to ground has to do with the 20 volts coming into the machine. So 20 volts comes into the machine around this fuse area. .500 ohms, that's not really too terrible. Okay. What about before that? Let's measure over here where it's going to be coming directly from the port. Alright, so the charging port itself is actually short-circuited to ground. The charging port itself is short-circuited to ground. It's going to be the port. So when you look on the schematic in the board view, what I'm looking at here is right where that 20 volts comes into the computer. So I'm not looking over there. 20 volts is coming in here, right from the port itself. And you saw what the port looks like. The port is corroded and beaten down and nasty. So there is a chance here that we may be able to save one of these ports, right? So the customer wouldn't have two, they'd only have one. Let's see if we can dig a short out of this, because there are customers that would be willing to pay for a partial repair, where instead of having two ports, they have one, but they pay less money. So where I see the nastiest section, what I'm going to try doing here is I'm just going to dig. And I'm going to dig all this shit out of here and see what happens. Because remember, I can't really give a discount on board repair if I have to replace this port, because this machine, this port is absolutely effing miserable to replace. It's a lot of annoying work. and the pins are really short. They don't actually make their way all the way through the hole. So soldering the replacement in is a nightmare. Getting this out of there is a nightmare. So what I could potentially do, if the customer's on a budget, which a lot of people during the COVID-19 era are, they say, listen, I can get you a working machine with one port. You'd have to use a dongle, which, let's face it, it's a fucking MacBook. You have to use a dongle to get most of your shit done with this thing anyway. You'd have to use a dongle. You get one working port, and I can give you a discount on the repair because it's not a full repair. But let's see if that's the case here. So we are going to try this. And we actually went from 4 ohms to 0 ohms. So no mas, that's not going to do it. We're not making any progress on that situation. So next up, what I'm going to try and do is remove the port and see if that removes the short. Also, what may make sense to do actually is remove the nozzle to my iron. You're going to get a worse view as a result of this, but I need to be able to do this properly, which means I need more heat, and I need the heat to be straight on, not at an angle. So you're not going to be able to see this well, and I do apologize for that. You're not going to get a good angle here, but you're just going to have to accept it because I need to be able to do this job properly. Now, what I'm going to do here is I'm lifting the board up like that. First, let me just change the focus here so that you can actually see. So what I'm doing here is I'm lifting the board up by the port. The reason I'm doing that is because the moment I've used enough heat to get this job done, the second I have used enough heat, I want that port to go get the fuck out of the board. I don't want to use any more heat than what's absolutely necessary. And there we go. Now here's the part about this particular repair that sucks. So all of these holes need to be, all of those holes are going to have to have all the solder removed. Your take on NYPD removing anti-crime unit? I don't know enough about it, man. I really don't. I think people are just so fed up on every end of the spectrum right now that decisions are going to be made without thinking them all the way through. You know, yes. Okay, so we got the port and the shield off, but let me explain what the hard part is here. This will cool off the BGA chip section, by the way. So see all of these holes over here? Not a single one of those holes is ready for a new port because they're all filled with solder. And and even if you use one of those vacuum pump things, it's never going to get inside of all those holes because of the size of them. I know my chat is going to fill up, but use a HAKKO 808 or an equivalent type tool. Or even worse, use a solder sucker from people who've really never used it for this type of work, who are going to claim that it works. You know those pieces of shit where you hit the button and a little piece of plastic jumps up and somehow that's actually supposed to suck up solder? But watch, we're going to go through this. I'm just going to add some leaded solder because it's going to be easier to remove from the holes, if at all. And then you go over it with wick. But the problem here is that it's not going to go inside the actual hole, and that's the part that sucks. So I'll show you later on that I removed the short circuit from the DC inboard. So see, when you suck up the solder, it removes all of it from some holes, some of it from all holes, but not all solder from all holes. And that's where this becomes the type of nightmare that makes you want to cry. Good luck getting all of the solder out of all the holes at the same time. That's not the way the world works. So I can show you a little hack that helps that happen. I can show you a hack that I use. For those worried about ripping pads, this is not an SSL J9000 console channel strip bus board. Those pads, this board just absorbs heat and keeps on going. Remember, this is an Apple product. Apple products cool themselves via the case absorbing the heat, because fuck if the heatsink fan that it comes with is actually going to do the job. So this board is pretty much a giant thermal brick. Those pads, this is not an iPhone. Those pads are not going anywhere. So I can be pretty mean to those pads. I don't have to worry about that. Also, yes, I know I have to reflow some of those diodes back into place that moved around, but that's for later. Now, every one of these holes, every last one, needs to be close to empty. And that's where this becomes not fun. So I'm using my GWIC, which you can get at store.rossmangroup.com. Don't delay, buy today. Hi, if you're editing this video, you better put a link to store.rossmangroup.com product page for GWIC there. Shill. And
don't delay, buy today.
Indeed, shill. Okay, so we do this. Now in some areas the solder comes out of the hole very easily. In others it will protest and not want to come out. So then you go to the other side of the board and you do the same thing there. Now, what I do once I get to the point that some of the holes don't want to be unstuffed is I take my wire cutter thingies. No, Ruslan, not even close. Hell no. And then I cut the wick to make it much thinner. I cut the wick and then I twist it like this. See, it's twisted. And then I'm going to take my hot air station, put a nozzle on it, turn it on, and I'm going to try to shove the wick through the hole while heating the hole. So you need flux for this. I'm going to grab the wick with the tweezer, and then I'm going to try to shove the wick through the hole like so. At some point your wick is going to start not cooperating like mine is. Again, you're going to have to take it, cut that used piece off, do it again. rinse, repeat over and over again. I'm not saying that this is a pleasant process. It is not a pleasant process. I'd be lying to you if I told you it was. It sucks. This process sucks really bad. Like, this is not a fun way to spend an afternoon. And at this point, the job is pretty brainless. You're not actually using your brain or thinking in any way. You're really just a janitor. It's also, I made the wick a little too thick there, so I'm gonna have to do something about that, or like grab it at the end and kind of shove it in the hole. Also, you want to be careful of the chips nearby that are underfilled, because you don't want to heat that stuff. It's very bad. Again, as much as this method can be aggravating, it's still much better than using a piece of shit solder sucker that doesn't actually work. Hamster work, high five. Indeed. At some point, you're going to totally run out of patience like I did, because the wick's not going to want to go through the hole anymore. Which is pretty close to where I am. But luckily, once you're at that point, you hopefully, somewhere around that time, you will be close to done, which is where I am right now. So I have a few more that I need to stick my wick through. A few more. And then after that, I really do hope that I am done. Yeah, so there's a couple here that haven't been cooperative. We're gonna grab the wick with the tweezer. Also, I gotta cut the ends of this because it's not threading in nicely. Yeah, the wick is not threading nicely. But now it should thread nicely. At some point, it's going to get more and more difficult to tell if there's still solder left in the hole, because you can't see all the way through the hole. Because every one of those holes, you may think, is clear, supposed to be clear, but it's actually a black hole to hell, because it's an Apple product. So you're not going to be able to see all the way through a lot of them. They may still have flux in them. You got some that are still going to be really picky. So I'm going to see if I can get my, what happens if I can get my tweezer through each one of these holes. See, the tweezer itself is too thick to go through the holes. That's how small these holes are. You can't get the tweezer to go through on the other side, which is absolutely crazy. It's hard to tell if what you have inside of some of those holes is dirty flux or actual solder. And again, you're going to reach the point like me where you don't want to use the wick anymore because you only get 1 or 2 uses out of it before it doesn't want to go through the hole anymore. And then you have to cut it up again. And that is going to require a certain level of patience. See, after it touches it a few times, it loses its pointiness, and then I can't get the damn wick through the hole again. So this is really something where you will find yourself losing your patience. See, like after 2 holes, I can't use this piece of wick anymore. And there's a lot of holes there, and I don't have the patience to cut up 60 different pieces of wick. That's not happening. But when you poke the wick through the hole, it is going to suck up the flux that's in the hole, which then answers the question, is that hole filled with flux or solder? So at this point, we're going to get another charge port, and we're going to smash it right through there. It's time for another charge port. My wick is absolutely fine, but the wick is sloppy because that's like saying that a paper towel is sloppy while you're in the middle of cleaning a mess. Like it's literally the piece that absorbs the mess. So naturally, the wick is going to be sloppy. If it wasn't, you would literally not be doing your job. Is there something wrong with your microphone? No, this microphone seems to be fine. I haven't noticed anything wrong with this microphone whatsoever, actually. Yeah, the microphone appears to be just fine. Get a desoldering pump. A desoldering pump is an awful way to do this job. A toothpick wouldn't work. You would need a needle. A needle would work, not a toothpick. You would need a sewing needle. But I don't have a sewing needle because I'm a MacBook repair person. If I did through-hole soldering on a regular basis, I would definitely have myself a set of sewing needles because a sewing needle is actually perfect in this instance because the sewing needle will also absorb the solder because it's all metal. But I don't have a sewing needle because I fix MacBooks, and I very rarely, if ever, do through-hole repairs. Let me get myself a port, and I'll be right back. Alright, so we got a port. So now, I believe that it was soldered in this way. Yeah, this went on the board like so. So I'm going to turn that fume extractor off because the thing's making me deaf. Turn this halogen light down because I'm going to kill it. That's my old port. You can't even see if the leads go through. That's the sad part. Because this... Here's the other thing that sucks about this. So this is through-hole soldering, right? This is through-hole soldering. But where are the holes? Where are the pins? Look, the pin only goes halfway through the hole. So soldering this in there, this ain't easy. This is not your grandpa's through-hole soldering, where once you were done getting the stuff through the holes, you took your fine-tipped flush cutters and went cut, 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 cut. Now I understand the reason for this. This is a very high bandwidth line. I mean, this is a line with Thunderbolt 3. You know, you're transmitting gigabits per second over this line. You don't want the leads to be acting as an antenna. I don't blame the fact that it is designed this way. It just may take away from the fact that I want to curse throughout the entire process while soldering it. So the first thing I'm going to do before I solder a new port, make sure you got rid of your freaking short. So the short is gone. As you can see, we had 4 ohms. I tried to dig it out, and I got to 0 ohms. Now we have 862 ohms. There, 0.862K is, 0.862,000 is the same as 862. So we push it in there. The port is going to be pushed in. And now what we need to do is solder it to the board. Or solder if you're in Europe or Australia. Now you want to make sure that it's pushed in there nicely, which it is here. I got that thing pushed in there nicely. And I also believe that on this side, the perimeter is going to wind up being... No, actually, am I right there? I think this actually gets hot aired on, because here's what I think is going to happen. I think that what goes on here is that this perimeter actually solders to the metal around the port. You need a hamster body to which you can switch. That makes no sense. You could have to redo Eugene's solder joints. No Eugene. No Eugene here. So I think this is actually going to be held in by more than just those little individual pins. So the first thing I got to do... My micro pencil seems like it just died. Okay, micro pencil's dead. Lame. So I think I might actually be hot airing this in from the top at first. And then I'll solder the individual pins. Solder paste is not a good thing to use here. You wind up with solder everywhere. You have smaller hands. Oh. Yeah, but I'd also be as dumb as a hamster. Alright, so first thing I'm going to do, heat this from the top and push it down. But I'm going to use less heat because I don't want to risk melting any sort of plastic inside of it. Alright, I'm pushing down because I want those pins to go deep into those holes to increase the likelihood that they will, when I solder them to each individual pad, it'll make it there. It's also going to take a while to dry because, I mean, it's going to take a while to cool off and dry and become solid because I have heated the entire board, not just a single area of it. So the reason that it usually dries quickly is because the rest of the board is cool and the board has a lot of thermal mass, so it will absorb the heat. So now I got all my pins there. Let me see if I can fix my micro pencil by unplugging it and plugging it back in. Turning it off and on again. Holy shit, that actually worked. Alright, looks like I have a micro pencil back, which is going to be much easier to use in getting this job done. So what I want to do is keep in mind that little pin is not coming through the hole at all. So it's not like I'm going to be able to have the pin touching the pad. I need the solder to actually make its way all the way through that hole and not have a cold joint. So I need to shove as much solder in there as I can and hope that it just marinates in there and eventually heats the pin because I can't touch the pin. The pin is untouchable. No, of course not, David. I just made that clear. The pins will not come out all the way. They are not long enough. It's my hope that if I use the micro pencil and I shove it in there, that I'm able to heat both the pin and the pad. But this is a hope and a prayer. Is it worth it to buy a cheap hot air station to work with first? It really depends. I mean, if that Atten 862, again, if I'm able to consistently get it and it costs in the low 200s, I really think that that's cheap enough that it's just not worth it trying to go for super cheaper. I get it when the really good hot air stations were $1,000 or $600, but they've come down in price enough that I don't see the point. I'd honestly rather reball an SMC than do this. I'll fix all the bridges and the joints afterwards. The first thing I want to do is just make sure that I heat the pin and the pad. You may be asking, why do I even bother clearing the holes if I'm soldering it from the other side using hot air to get it in there to begin with? Well, that is because I'm an idiot. I don't think anybody would argue with that. I need to use the large iron to get rid of the bridging anyway, so I figure I might as well. What I'm hoping to do is heat the pin in the pad and just have this giant thing of molten solder over it that kind of with fresh flux that falls right in. Alright, now what I want to do here is push the charge port into the board again. I'm going to do another just to make sure that it's every single one of those pins gets hot and gets to touch the solder. And that since there's new flux there, that I'm not making the joints cold by doing this. I'm letting the air out at the bottom of my mat. And I'm pushing down on the port. I'm going in really close with the hot air now. Letting it dry. We let Rapid Cool technology do its thing. Rapid Cool technology. Rapid Cool technology. Coming to a store near you. Now, while I'm in the process of waiting for this to cool off utilizing Rapid Cool technology, I might as well do two things at once. I thank you very much there, Byron. I'm going to use this as an opportunity to clean my desk. Make it look a little nicer. Get ready for the next repair if this one is done. Can't hurt to be clean, right? The rapid cooling process has completed. So now I'm going to plug the charging in. And honestly, if I just don't have a short to ground on output, that'll mean I made some progress and I can be happy with something. Let's see what happens here. Let's see if I made any progress worth being happy about. DC in. Is it this one or this one? Well, that's not a short. That's not a short. Okay, what happens if I plug this in? Now this port says 5 volts, 37 milliamps. It does not appear to go to 20 volts. However, it also does not take 800 to 900 milliamps and die, which is a good thing. Let's see what the other port does. So that one's boot looping. Also, I'm curious what voltage I get on PP3v3. Alright, so most likely our the CD3215s could use some replacing, which is not surprising given that the board looks like total shit. It's not surprising in this instance that the CD3215s would be damaged and need replacing. So it's no big deal. We're just gonna take them out, replace them. I don't have a nozzle on my iron, so I'm actually just gonna be lazy and remove them without the nozzle on my iron. I don't need a nozzle for this. Yeah, you could see that there was a good chance that those balls were touching underneath there. One of the resistors slid over a little, but that's no big deal. I can always slide that right back into place. So what needs to be done now is two CD3215s need to be placed. So I'm just going to go get some. Okay, so we have ourselves some replacement CD3215 chips. Now, I'm going to have a little bit of the flux go on that resistor, because remember, I want to flow that resistor back into place. Also, you can see when I used wick over here, that on the left side, there is a resistor that had its solder removed from it. Yeah. I should put my nozzle back in place here. I moved it a little bit when I was drying, which was stupid. I don't want to have a cold joint as a result of that. Alright, so now we let the rapid cool technology rapid cool. Okay, rapid cooling. Now we have two new CD3215s and a new charge port. All the corrosion has been removed. At this point, I would expect to see alternate results. Nothing? Nothing. So we went from 5 volts, boot looping 24 milliamps, to the charge port is not even connected to the freaking board. You're trolling me. You're trolling me. Ugh. Okay. Now that could be either the CD3215 issue, or it could be that my charge port moved a little. I honestly don't know which one it is. And I don't have a particular way to tell. Some of those joints look a little cold, only after putting all the heat on for the CD3215 reflows and replacements. So we're going to try doing that. I'm going to add yet another line of flux down there and up there. And I'm going to push down as I push the connector onto the board again. I really don't believe that the chances are that I soldered both CD3215s so improperly that it refuses to make any, that both ports are giving me nothing. That's really difficult to believe. An easier sell for me would be that something moved here when I reflow those chips in my charge port. So $20, $19, $18, $17, $6, 15, 14, 18, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Alright, now we go in close, and I'm going to push. At this point, I'm being trolled. This is an absolute effing troll. Either that or I got fake CD3215s. Wonder what the possibility is of that. That is kind of ridiculous. Doesn't actually even recognize it anymore. Did my charger take a shit? No. Charger does its job. If I push, Duke got a bunch of fake CD3215s, and I'm kind of wondering if that's what I have over here. That would certainly be some bullshit. But I think that may be the case. This resistor looks out of place. What the hell is that thing for? Wait, you are out of place. What the hell is this shit? Oh, son of a bitch. Put the fuck back down there. You fucking troll. I still don't think that would cause both ports to read nothing. Five volt, 38 milliamp boot loop. 5 volt, 38 milliamp boot loop. Other port. Nothing at all. Okay, so the bottom port is probably going to go to the CD3215 that is to the left. That's a resistor? It's a critical resistor. And that looks like shit. Someone said missing cap on the right, CD3215. That's a resistor, and I think it's no stuff. Fairly certain that that is no stuff. But I'll double check and make sure. Yeah, there is a missing resistor there, not a cap. The board looks like shit. Oh, it sure does. Alright, so we put back the stuff that was missing, but we still have no difference there. The bottom port boot loops after a few seconds. And the top port, the top port actually does have some action now. But the top port also boot loops. This is with two new CD3215s, so both of the CD3215s are boot looping. So let's see if I missed anything else here. I'm going to compare it with the donor. So that resistor that's missing there is actually supposed to be missing. Where is this? There's a diode I knocked off down there. For a CC1 and CC2 connection. That's, I believe, data. I'm going to give this a quick ultrasonic cleaning. Let's start off with something a little cleaner. Although I'm fairly certain that I'm going to call this an evening and say fuck this board. Die, troll board, die. Die, troll board, die. This board belongs on Paul's desk in Paul's queue, where it can torture Paul. The Paul desk, the Paul queue. The superior queue. The superior desk. I knew this was not going to be a fun one. I knew it was going to be miserable from the moment that I started. And for some reason I persisted, because I'm stubborn like that. That's the sound of my ultrasonic cleaning machine going vroom. The ultrasonic goes vroom. The ultrasonic goes vroom, vroom, vroom. Vroom. I gotta wait for the board to dry. A lot of people ask me, why don't you show us the ultrasonic or what the board looks like before and after? Because waiting 30 minutes for a board to dry is actually a really boring stream content, as you're about to find out. Yep, literally sitting there watching an empty camera as a board dries is some low quality content. Very low quality content, actually. I'm submerging it in some 99% alcohol, tossing it around, using this squirt bottle to get underneath chips forcefully. Now the board can go into the oven. And in the oven, it's going to dry it all off. Alright, so we're back from the ultrasonic cleaner. If you were just watching the stream, you probably listened to me rant and go on for about half an hour over bullshit. Anyway, now that we have gone over the... fixed it... Now that we've ultrasonically cleaned it, you can see that over here, this is the section where there was the 20 volts, where I was trying to remove all the corrosion. The ultrasonic actually did a really good job of cleaning that up. Now, we had some nasty stuff over here by the backlight circuit, which the ultrasonic has cleaned up. That's not really what matters. But what matters over here is you can see this chip is actually moved a little bit, most likely when I was using a lot of heat to remove the charge port and also solder that charge port back on. And if you take a look at the schematic in the board view as to what it is that chip is, that is actually the Thunderbolt ROM. And you have to keep in mind that the issue here is that my USB-C charger, which is technically Thunderbolt, is not working. So if we take a look in the schematic, let's look for U2890. Yeah, that is the Thunderbolt ROM. That is going to be communicating with the Thunderbolt chip. That's going to be communicating over here. That communicates with the Thunderbolt chip. And one thing to understand is that this over here is actually going to be communicating with U2800. So U2800 is the main Thunderbolt controller. Take a look at this. This is the brains of Thunderbolt. There's one page where it shows all the things that speak to one another. I guess not. Let's see, U3100. Alright, that speaks to the system management controller. Well, either way, we're going to flow that little thing into place over there. And once it's flown into place, you'll see that the board just turns on and works the way it's supposed to. I will get to go home with a happy little victory. And this is where the ultrasonic cleaner can help me out a little ways, help me correct my idiotic mistake over here. I imagine once the SPI ROM is actually put on the board properly that we're going to see 20 volts. If we do, I'll be really happy. And if we don't, I will then probably take this board and throw it in the river, to be honest with you. That's the essential way to go about this. So someone says the second cap on top of the chip doesn't look good, but I actually think it looks fine. This whole X section, really, I don't have any complaints there. So we're going to take this. We're going to plug it in. Plug it in, plug it in. And see what happens. As you can see, we're getting 20 volts now. That's 20 volts, 17 milliamps. So we have solved our CD3215 problem. So that is solved. Now we have to get to our next question, which is why doesn't the machine turn on? 20 milliamps is not enough to actually turn this thing on. We could take a look at things like PP Bus G3 Hot. Maybe we take a look at our PP Bus G3 Hot, see where that is. Let's see. PP Bus G3 Hot is down here. It's 12.9, 13 volts, so that is what I would expect it to be. However, we don't get any turning on from this computer. And that is one of the things with these machines where it really is going to keep drawing me in, because I just made a little bit of progress, and that little bit of progress that I made makes me want to get reeled back in to figure out what the actual problem with the board is. And that's going to wind up keeping me here until 1 in the morning. That's the way this always works. Now if we take a look at the power rails over here, let's see. Let's see. So what power rails are we supposed to have over there? We're supposed to have PP5ES5, which we don't have. Let's plug this back in and see for sure. Five volts, 5 volts, 2 volts, 5 volts, 2 volts. Now normally the TPS 51980 flips out So you have PP5ES5 going up and down and up and down, and usually that happens when one of the power rails that's created by U7650, which is the TPS 51980, is shorted to ground. So let's just check what we have here. So pin 2 of the chip is supposed to be PP5ES4, one of the rails that's created, and I'm just going to see if we have that. So we have... So that's not shorted to ground. Now we could check rails like PP3V3S5 and see if that's shorted. That's not shorted either. So none of the rails that are actually created by that chip have any sort of short on them. But that doesn't mean that the rails that are upstream of it are not shorted. So perhaps it's only shorted when it's on, which means it's an S3 or an SO rail that's bad. Let's check PP3V3SO and PP5ESO and see what's going on there. So I'm going to search for PP5ESO. PP5ESO. And let's see if that is shorted. So PP5ESO can be found right by the backlight chip. Let's see what we got there. $24 kiloohms to ground. That's not our problem. And PP3V3SO. It's going to be on this little cap over here. Or non-existent cap over here. 3 kiloohms. That's strange. Okay, so now we have to figure out why that TPS 51980 is turning on and off and on and off and on and off and on and off. Because none of the rails that are even upstream from that appear to have any problems. Now our enable is going to be on pin 12 for PP5. Let's see if that is jumping. Oh, duh. Voltage. The enable is turning on and off. And the enable is going to come from this, which comes from the PMIC. Which I'll give a quick reflow to before we give this over to Paul. Paul's going to have a lot of fun with this one. This is probably a stupid thing to do because the reason that's jumping up and down is because there's some sort of short circuit somewhere. Not because of the chip itself, this chip itself that's making the enablers bad. The problem is I have no idea what could possibly be short-circuited because I've measured all these different rails and there's nothing shorted on them. I think I didn't check PP3V3S4 and PP3V3S3. PP3V3S4, I guess I could check that. There we go. There we go. There's the short. So PP3V3S5 is created by the TPS51980 chip, which you see over here. Now, PP3V3S4 is also going to be created from PP3V3S5. So what's powered by PP3V3S4? That's a great question. So something powered by PP3V3S4 is shorted to ground and fucking up my entire system. Now we need to figure out what it is on this line that it could be. So I'd like to try and see if I can figure it out the quick way without injecting voltage by just looking through stuff and seeing what looks really nasty. So what do we have? So up here, got water damaged in this area. However, this stuff, that's no stuff. That's not even on the board. Those are resistors. That doesn't even have a path to ground. Those don't have a path to ground. That cap has a path to ground. Could that be it? Maybe. Or there's this. Our little friend up here. This cap was one of the ones that I actually thought was bad. That up there, that's the cap that I actually put back on the board. You mother. So we're going to take that little bastard cap off of the board. And see if that changes our short circuit condition. I trusted you. I almost knocked you off and I put you back. Oh, man. Wow, what an absolute thriller of a board repair. 29 kiloohms to ground. At this point, I should be taking 500 to 600 milliamps, and you should be working. There's no reason for you to not turn on. I see 100 milliamps. I want to see 400 to 600. You better give me 400 to 600, you little bastard. Yes! Fuck you, Apple! Alright. Now let's see if I get a logo on the screen. $700 milliamps, 800 milliamps, 900 milliamps. Give me a question mark, you fuck. .2 volts on backlight. We have 43 volts on backlight. I should be getting a picture here. Let's see what happens if I have an SSD attached. I should be getting at least a question mark folder. I know it's going to boot slow because I don't have the trackpad or any of the sensors plugged in. It's weird because if it wasn't detecting the screen and giving me no picture, I would not expect to have any sort of backlight voltage. Bada bing, bada boom. It works. Fixed! So let's go over what was wrong with this MacBook. The first issue that we had was that when I plugged it in, it was not showing anything on the charger at all. I checked the area and there was a lot of liquid damage. And then
At sometimes I could get it to take a full amp at 5 volts, which is really weird. I thought there's a short to ground, probably somewhere on the input, and I checked the charger voltage coming into the machine and the charger voltage coming into the machine. That power line had 4 ohms to ground. I tried to dig it out of the charge port itself, and by digging into the corroded charge port, I then had 0 ohms to ground. So I replaced the charge port, which is a painful, annoying process, and it still wasn't working. It was giving me different, so I changed the CD3215s. However, the actual thing that I needed to do in addition to replace the CD3215s was move my ROM chip, because when I was using the amount of heat that I need on this board in order to get that charge port to sit the way it needs to sit, I managed to move the ROM chip. I moved the ROM chip back into place, and I was getting 20 volts, but it was only taking 80 milliamps, which is not enough for it to turn on. I decided to check around the power rails in the board, and I started with PP-Bus G3 Hot. That's the main power rail after PP3v3_G3 Hot is present, which obviously it was because we're getting 20 volts on the board because the CD3215s, which are powered by PP3v3_G3 Hot, were turning on. This was PP-Bus G3 Hot. We needed to check that. We saw that that was 13 volts. Once that was 13 volts, then we go down the line. PP5ES5, PP3v3S5, all of those power rails were flickering. That tells me that there's something wrong with the power rail that's related to that chip. So that line was going up, down, up, down, up, down, because one of the lines that that chip creates, or that's created downstream of the lines that that chip creates, was shorted to ground. That's the behavior that you get. PP5ES5 or PP5ES4 or PP3v3S5 going up, down, 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 up, down. Die, Corona, die! That is a symptom of one of those being shorted to ground. Now, PP3v3S5, PP5ES4, PP3v3S5, all were not shorted to ground. However, you have to keep in mind, PP3v3S4 and PP3v3SO are created from PP3v3S5. PP5ESO is created from PP5ES4. So what we did is we checked every other one of those rails. PP3v3SO, not shorted. PP5ESO, not shorted. PP3v3S4, shorted. By the little cap that I refurbished on the corner. I tried to not knock you off the board. I wanted you to have a seat at the table. You betrayed me. Shame. Yeah, and you could tell that I stayed at work late for this one because I no longer have a mask on. For those who wonder, when there are 14 employees and 3 or 5 customers in the store, I have everybody wear a mask. When I am by myself and the store gate is closed, the door is closed, and there's nobody here in a 2,400 square foot space that has air filters all over the place, I do not wear the mask. The mask is not to protect me. The mask is to keep me from giving it to others in the case that I got it, and it's very difficult to get a test, very difficult to know if you got it, since there is that 2-week period where you are not really symptomatic. So again, I know I'm not wearing a mask in an empty room. I'm wearing a mask in a store with 14 or 17 or 20 people in it. But when it is 9:30 at night and nobody is here, I don't wear the mask. And when I'm done, I like to take my little alcohol sprayer. I go all over my desk in the areas that I was in. I clean everything off from the front counter to the door handle and all that. And I go, die, Corona, die! Feels good. It's fun. So that's it for today. And as always, I hope you learned something. Hi, have fun editing this one.